Next, we will look at some theorems involving triangles. So here we have been given a statement which says that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and also half of it, right? So we have been given a triangle ABC and we have been told EF and E and F are midpoints of AB and AC respectively, and the line segment EF is joining those two midpoints, and we are required to prove that EF is parallel to BC, which is the third side, and also EF is half of BC, so it is half of the third side. So in order to prove this, we need to do some construction. First, let's draw CD parallel to BE or BA, and then extend EF to meet CD at D. So this would form a quadrilateral BEDC as you see here. So now let's try to prove this theorem. So consider the triangles AEF and CFD. So these two triangles. So we know that angle EAF and angle FCD. So angle EAF and angle FCD. These two angles are equal because they are alternate angles, because AB is parallel to CD from construction, and we know that AC is the transversal. So these two angles are alternate angles, so they are equal to each other. Similarly, we know that AF is equal to CF because F is the midpoint of AC that is given, and we also know that angle AFE and angle CFD are equal to each other because they are vertically opposite angles. So if you observe in these two triangles, we have two angles and their included side are equal. So these two are congruent to each other from ASA theorem. So when two triangles are congruent by the ASA theorem, we know that the corresponding sides of these two triangles are also equal. So AE should be equal to CD. So AE and CD are equal. But we know that AE and BE are equal because E is the midpoint. So AE and BE are equal. So we know that in this quadrilateral BECD, BE and CD are parallel to each other and they are also equal in length. So BECD is a parallelogram, because a quadrilateral in which the opposite sides are parallel and are equal is a parallelogram. So which means ED and BC are also parallel to each other, which means that EF is parallel to BC, right? EF is parallel to BC. So that is what we have proven here. And next, we also know that ED is nothing but EF plus FD. But ED is equal to BC because opposite sides of a parallelogram. So EF plus DF is equal to BC. But we know that EF is equal to DF because we have proven that these two triangles are congruent. So these two sides must be equal, right? Because substituting DF with EF, we get 2EF equal to BC. So which means EF is equal to half of BC. So we have also proven that the line segment joining the midpoints of two sides of a triangle is parallel to BC and also half of the BC, which is the third side of that triangle. Now let's look at another theorem. Here we have been told a line drawn through the midpoint of one side of a triangle and parallel to another will bisect the third side. So here we have been given ABC as the triangle. E is the midpoint of AB and EF is a line segment parallel to BC and intersecting AC at F. So we have to prove AF is equal to CF, which is the third side. So basically AB is one side of the triangle which has a midpoint E, and a line segment drawn through the midpoint of one side of the triangle and parallel to the other side, which is BC, will bisect the third side AC, which means AF should be equal to CF. That is what we are required to prove. So in order to do this, we'll do the same construction as before. We'll draw CD parallel to AB and we'll extend EF to meet CD at D. We know that angle AEF is equal to angle CDF because AB is parallel to CD, ED is the transversal, So these two angles are alternate angles. So they are equal. Similarly, we know that angle EAF is equal to angle FCD because these two lines are parallel, AB and CD, and AC is the transversal. So these two are the alternate angles. So if we prove that AE and CD are equal, then we can say these two triangles are congruent by ASA theorem. So let's try to see if we can prove AE is equal to CD. We know that AE is equal to BE because E is the midpoint of AB. But we also know BECD is the parallelogram because we have been given EF is parallel to BC and we have constructed CD parallel to BE. So this is a parallelogram. In a parallelogram, opposite sides are equal. So BE is equal to CD, but BE is also equal to AE, which means AE is equal to CD. So hence we can say this triangle and this triangle are congruent to each other, which means that AF should be equal to CF because they are corresponding sides of the two congruent triangles. Hence we have proven our statement, which is AF equal to CF, which means that EF is bisecting AC. So basically we have proven that a line segment drawn through the midpoint of one side of a triangle and parallel to the other side will bisect the third side.